Welcome. In this video, we're going to see a comparison between recursive and iterative algorithms, so you know which to choose in every case you encounter. So, in reality, recursion and iteration are two sides of the same coin. We just want to do something repeatedly or compute a value incrementally, and to solve that problem, we need to repeat a few instructions. So we can either use loops and keep looping through, or use recursive calls and use a conditional to stop. So both have some sort of stopping condition and control structure. So both require a termination condition, in that both need to have a well-defined end to them, otherwise we'll have an infinite execution, either by iterating infinitely or by recursing infinitely, even though in the case of Python, for example, you cannot recurse infinitely, as you will encounter a Stack Overflow error. And any algorithmically solvable problem that you can find, if you can solve it iteratively, you can also solve it recursively. So both paradigms are valid solutions to any problem that you might encounter. However, the solutions might be more easy to understand in one or the other. So for example, the factorial that we have here down below has the same conditional n equals 0, and n starts at the initial value given by the user, and here n goes down to 2 because the 1 would multiply by 1. But the difference is that for recursion, this method will use far more resources than the iterative one. So for example, the iterative one will use one method call, which would be the call itself, and then it will use a couple variables to store the result and the counter for the loop. And that is all. Even though it will use the same amount of operations in memory than in the CPU than the factorial in recursive form, this one will be much more memory efficient. However, this one will create a new call every time it wants to solve the factorial of the n-1, and thus you can encounter the Stack Overflow if this is not correctly sized for your computer, or if your base case is not correctly implemented. However, the advantage of recursion is that it's much simpler to express mathematical ideas with it, and it can be more understandable to think of these as a function defined in parts, very easily translated back to the math concept. Let's see a couple algorithms and compare them. For example, we have the factorial here, and this would be the iterative implementation of the factorial, as we've already seen. Here we have a bit of a trick with the range, going to from 2 to n+1. Remember that we need to add the 1 such that n is included in the range, because the end parameter of the range is non-inclusive. And we can start at 2 because 1 is already included, and multiplying by 1 would not change the result. Then we can also have the Fibonacci implementation, both in recursive and iterative. And you can see that the recursive implementation is much closer to the mathematical expression and the equations that we use to describe Fibonacci in real life. You can see that if you have an equation defined by parts in a recursive way, it's very easy to translate it to a recursive method, as long as you know the basics of the syntax in the language and can assign the base case and the general case. And converting it to an iterative implementation might be more efficient memory-wise, but might not be as quick to understand. In this case, we're starting the Fibonacci sequence at 0, 1, and on every step, and we are going to perform n steps, we are assigning a to b and b to a plus b. So in each case, each time we're computing b as the sum of the two previous values a and b. At the end of the sequence, we return b. This is of course very efficient. We only use 3 variables and the range call to generate the sequence of numbers from 1 to n-1. Remember that n is not included. But it might be much more easier for someone to understand the general formula of Fibonacci by taking a look at the recursive version than when taking a look at the imperative version. Both solutions are correct, and in most computers they will run just as quick and just as fast. However, it's up to you to choose every time whether you want to implement a recursive or an iterative method. And that is all. I'll see you on the next video.